called matrices, right? In the previous week, we discussed relations and functions over. Now today, matrices. And in matrices, you know very well A plus B, A minus B, you can do it. Okay. But where to concentrate actually? What is called a matrix? You know very well. The arrangement of some complex numbers, like any real numbers. The arrangement of some complex numbers in a rectangular array is called a matrix. Okay. So either row wise or column wise. You know all those things. Very easy chapter. Okay. But you should concentrate on general representation of matrices. Okay. Let me discuss what is called a matrix. The arrangement of some complex numbers in a rectangular array means either row wise or column wise is called a matrix. Right? Matrices are represented by parenthesis, double bar, or any square brackets, and they are denoted by capital letters A, comma B, comma C, and so on. Right? So there is no need to do that one. And next one, it is class of the matrix. This is important. Class of matrix. You know very well. Class of matrix, or order of matrix, or type of matrix, or size of matrix. The meaning is same, right? Now, if a matrix consists of m rows and n columns, then the class of the matrix is represented by m by n. Okay, definitely you should represent the rows first and after the columns. I repeat, the class of the matrix is, if a matrix consists of m rows and n columns, then the class of the matrix is represented by m by n. Suppose, for example, A is equals to 1, 2, 3 given to you, then it is of 1 row, 3 columns. So it is of order 1 by 3. Okay. Now, general representation of matrix. This is very important of matrix, which is called as capital A is equals to Aij. Like, you know very well, A11, A12, you have done so many exercises also, A1J, A1J, A1N, nth column, right? A is an element in the second row, first column, second row, second column, second row, jth column, second row, nth column. Similarly, A is an element in the ith row, first column, ith row, second column, ith row, jth column, right? And ith row, nth column. You know very well. Similarly, A is an element in the mth row, first column, mth row, second column, mth row, jth column, right? Mth row, nth column. It represents the matrix which is of m by n. This is called as general representation of matrix. You can write this one as Aij of m by n. While types of matrices comes to this one, you can take the screenshot of this if you want. While we come to the types of matrices, okay. Now, what is called types of matrices? What is called row matrix? What is called a row matrix? A matrix which consists of a single row is called a row matrix. Means capital A is a matrix. Now itself we have given one example, like whatever may be the columns. Okay, if you have only one row, so it is said to be row matrix. One row, 3 columns. Okay. Now next one, it is column matrix. A matrix which consists of only one column is said to be column matrix. This is 3 rows, 1 column, right? And square matrix, a matrix in which number of rows is equal to number of columns is said to be a square matrix. This is also called as second order matrix, right? Or second order matrix is said to be B. Let me consider only one element. Okay, this is called as 1 by 1. This is also a square matrix of first order matrix, right? Now, capital C is equals to, let me consider 1, 2, 3, 4, 5, 6, 7, 8, 9. This is called as 3 by 3 matrix, which is also called as third order matrix, right? Now, in this one, you can represent these three like with only one word called Aij of m by n, where m is equals to n. This is important. This is called a square matrix. If m is equal to n, it is called a square matrix. Next one, it is a rectangular matrix. The matrix whose number of rows is not equal to number of columns. That is 2 rows, 3 columns. Okay, it is said to be rectangular matrix where m is not equal to n. M is not equal to n. Copy this one. Copy this page. Now, everyone knows about these row matrix, column matrix, and all those things. But theoretically, how you should write this? Okay. First of all, a row matrix means it should have one row. That means Aij is equals to capital A is equal to, I am writing here, you just observe, and you should write it as adjacent to it. A is equal to Aij of 1 by n. Only one column, only one row, n columns. And here, capital A is a matrix of m rows, 1 column. Okay. Now, third one, Aij, capital A is equals to Aij of m by n, where m is equal to n. In front of that square matrix, you should write this much. M is equal to n. These are important. He is going to give you 4 options. Okay. In those 4 options, which one is a square matrix, which one is rectangular matrix, he is going to ask you, right? This one, A is equal to Aij of m by n, where m is not equals to n. Copy this one. we have copied it. Okay, let me go to the next page. Now, what is called principal diagonal? See here. Now, what is called principal diagonal in a square matrix? Suppose if capital A is a square matrix, 1, 2, 3, 4, 0, 5, okay, 0, 0, 6 is a square matrix. The diagonal from which from the first row of the first element to the last row of the last element is said to be principal diagonal. Okay, that means 1, 0, 6 are the elements of principal diagonal. I repeat, the diagonal in a square matrix, the diagonal from the first row of the first element to the last row of the last element is called principal diagonal. Okay, and the elements of principal diagonal are 1, 0, 6. Okay, now you are having one concept called trace of capital A, trace of matrix. What is the meaning of the word? For CET is important. Trace of the matrix. What is the trace of the matrix? Okay, the sum of principal diagonal elements is called trace of the matrix. The sum of principal diagonal elements is called trace of the matrix, and it is represented by C, and it is represented, suppose if capital A is any matrix, then trace of A is given by like this, which is equals to, see here, the trace of A is 1 plus 0 plus 6, which is equal to 7. Okay, now you are having properties of the trace, right? What are the trace of the matrix? Trace of A, I think you know this one. Trace of A plus B is equal to trace of A plus trace of B. Trace of AA is equal to K into trace of A. Trace of AB is equal to trace of BA. But trace of AB is not cannot be determined as trace of A into trace of B. Okay, those are the properties which you know very well rather than me. Right? Now this is called trace of the matrix, and next to side heading it is called scalar matrix or diagonal matrix. What is called diagonal matrix? Okay, a matrix except the principal diagonal elements, remaining elements are 0. Means suppose see 1, 0, 0, 0, 2, 0, 0, 0, 3. This is called diagonal matrix. If capital A is equal to this one, you can also write this A as diagonal A. This is the diagonal matrix called diagonal of 1, 2, 3. Okay, this is called diagonal matrix. Now, upper triangular matrix. In a square matrix in which the elements below the principal diagonal are 0, means observe here 1, 2, 3, 0, 4, 5, 0, 0, 6. This is called as an upper triangular matrix. In the matrix, in the square matrix, if the elements below the principal diagonal are 0, is called an upper triangular matrix. Now, the next one, it is lower triangular matrix. The elements above the principal diagonal, 1, 0, 0, okay, 2, 3, 0, 4, 5, 6. This is called lower triangular matrix. That means it is reverse. Actually, that means it is going to form a triangle lower side of the principal diagonal. Okay, then it is said to be lower triangular matrix. Blind identification is the elements above the principal diagonal are 0, then it is said to be lower triangular matrix. If the elements below the principal diagonal are 0, it is said to be upper triangular matrix. Right? Now, how can you write this diagonal matrix theoretically? This is very important. You should write it now. How, sir? Capital A is equals to Aij. Capital A is equals to Aij of M by N, where I is not equal to J. Okay, and Aij is equals to 0. You should write like this, no? This is very important compared to your definition. Okay, that means he is going to give you 4 statements. Okay, in those 4 statements, which of the following is diagonal matrix? He is going to ask like this. So at that time, you should remember this. Okay, now. Next one, scalar matrix. Okay, what is called a scalar matrix? A square matrix is said to be scalar matrix if the principal diagonal elements are identical other than 1. Means, example, if A is equal to 4004. This is one type of scalar matrix of order 2, right? And this is another type of scalar matrix of order 3. Right? So, now, how could you write this one scalar matrix like capital A is equals to Aij? It should be square matrix number, means it should be square matrix, means M value should be equals to N. Or you can also write this one as N by N matrix. Okay, is said to be scalar if Aij is equals to 0 when, this is very important, I is not equals to J, Aij is equal to K when I is equals to J. Okay, where K is constant. Copy this one. Where K is constant. who is that me, ma? Can I speak with him? Ma, who is that me? Hello? Ma, who is that me, ma? Useless fellow. Yes, right on. Right on the next problem. Next one. Identity matrix. What is called an identity matrix? The square matrix, a square matrix in which the principal diagonal elements are unity. Unity means 1, 1, 0, 0, 1. It is called an identity matrix of order 2. Okay. And I3 is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. It is equal to I3. I3 value is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now, how to write this identity matrix in theoretically? That is, capital A is equal to Aij, which is equals to 1 if I is equals to j, and 0 if I is not equals to j. Copy this one. Ma, these are important, ma. I think after that, you know, addition of matrices and multiplication of matrices. Okay. And that means how to write it theoretically, that is important. On multiplication, we are going to get, suppose, on addition of matrices, theoretically how to write. All know how to do A plus B. Okay, I think you know how to do A plus B, A minus B like that. But even you know the properties also. But theoretically, you should write if A is equal to Aij of m by n. Okay, B is equals to Bij. Okay. Bij of n by p. Okay. Then A plus B does not exist. What is the order of this? A plus B does not exist. Why? Because A and B are not having same order. Okay, if A comma B have the same order, then A plus B exists. Otherwise, it does not exist. Okay, copy this one. I'm repeating this. If A is equal to Aij of M by N, B is equal to Bij of N by P, then A plus B does not exist. Right? Now, the second thing, addition is possible if A comma B have same order. Means A is equal to Aij of M by N, capital B is equal to Bij of M by N, then A plus B is equal to Cij of M by N, where C is equals to Aij plus Bij. Copy this one. Okay, so this is about addition of matrices. Now, multiplication of matrices. If A is equal to Aij of M by N, multiplication. A is equal to Aij of N by N, B is equals to Bij of N by P, then AB exists with order M by P. Okay. Now you can ask me, that means on this problem, on this one, you are going to get one problem like order of A is equals to 3 by 4. Order of B is equal to 4 by 3. Then AB order becomes this one get cancelled. It is 3 by 3. Suppose for the same question, he asked you BA order, BA does not exist. Why? Because if you want to get BA exist, okay, if you want BA to be exist, number of columns in capital B should be equals to number of rows in A. Then only BA exists. Otherwise, BA does not exist. See here, AB, A is equal to 3 by 4, B is equal to 4 by 3. Number of columns in capital A is equal to number of rows in B. Okay. Similarly, if you want BA to be exist, number of columns in B should be equal to number of rows in A. Okay. So this is about multiplication